In the most inhospitable corners of the Arctic, the barrier between life and freezing death is often just a pane of glass. Here, amidst the eternal winter, a beacon of advanced agriculture stands defiant against the polar night. Engineered to withstand hurricane-force blizzards, the steel skeleton holds the weight of the world. Entry is a calculated procedure. The heavy metal airlock separates the lethal cold from the sanctuary inside. Every trace of the outside world must be left at the threshold to maintain the sterile integrity of the ecosystem. The temperature differential is immense. Even in the buffer zone, the cold clings to the technician. Before proceeding, a high-pressure decontamination mist neutralizes any potential pathogens carried in from the wild. The heavy layers of Arctic survival gear are shed, revealing the clean room attire required for the delicate work ahead. Hygiene is paramount. Nitrile gloves provide the final barrier between human skin and the sterile crop environment. Crossing the threshold into the main cultivation chamber, the stark white gives way to the hum of life support systems. This is the heart of the operation. A hydroponic cathedral bathed in the specific light spectrums needed for accelerated photosynthesis. Beneath the floor, geothermal heating pipes circulate warmth harvested from the Earth's core, fighting the Arctic freeze. Conditions are monitored with obsession. 24 degrees Celsius, 60% humidity, a tropical microclimate inside the ice. The cycle begins with a sterile seedling tray retrieved from the disinfection rack. The workspace is stainless steel, easy to sanitize, ready for the seeding process. We use compressed cocoa coir as a substrate, sterile, renewable, and excellent for water retention. Warm, reverse osmosis filtered water is added to expand the fibers and wash away any residual salts. The texture must be perfect, damp like a wrung-out sponge, ensuring oxygen can still reach the future roots. The substrate is distributed evenly into the tray cells, creating a uniform bed for every potential plant. A gentle impression, exactly 1.5 centimeters deep, prepares the nest for the seed. We select F1 hybrid corn seeds, specifically bred for cold tolerance and short growing seasons. The seeds are inspected for uniformity. Each one is a capsule of potential energy. Precision handling ensures no damage to the seed coat before planting. Oriented vertically, the seed is placed deep enough to anchor, but shallow enough to break the surface quickly. This process is repeated with rhythmic efficiency. Every cell is an opportunity for a harvest. A light blanket of media covers the seeds, protecting them and maintaining the humidity needed for germination. A gentle mist seals the surface, ensuring immediate contact between the seed coat and the moist substrate. Data tracking is essential. Batch number, date, and variety are recorded to monitor performance. The tray is moved to the germination chamber, a high humidity environment designed to wake the seeds from dormancy. We seal the chamber to maintain 90% relative humidity and total darkness, mimicking deep soil conditions. Inside, biology takes over. The moisture triggers enzymes, and the seed swells until the soil surface breaks. First comes the radicle, the primary root, driving downwards to anchor the new life. The coleoptile pierces the surface, shedding the protective seed coat to unfurl the first leaf. Driven by geotropism and the hunt for light, the stem straightens and reaches upward. After 48 hours, we check for uniformity. Only the strongest seedlings will proceed to the hydroponic stage. The tray is moved to the nursery zone under full-spectrum LEDs to initiate vigorous photosynthesis. While the seedlings harden off, we prepare the nutrient film technique, or NFT system. Hydroponic corn creates a heavy demand for calcium and nitrates, which we mix into the primary reservoir. A magnetic industrial mixer ensures the solution is perfectly homogeneous, preventing precipitate formation. Next, part B is added: phosphorus, potassium, and micronutrients, kept separate until now to avoid chemical lockout. We target a specific part per million concentration. Too weak, they starve. Too strong, they burn. pH is balanced to exactly 6.0 using organic acids, unlocking nutrient availability for the corn roots. The heart of the system starts beating. Nutrient-rich water begins its journey through the channels. Transplanting requires a gentle touch. The seedling is lifted from the nursery tray. Excess media is removed to prevent clogging the pumps, exposing the healthy root structure. The plant is placed into a net pot, the standard vehicle for hydroponic suspension. Expanded clay pebbles, leca, are added to support the stem and block light from reaching the nutrient stream. The assembled unit drops into the system. From this point on, the plant's life is entirely aquatic. Beneath the surface, the roots instantly sense the flow of water and begin to drink. Corn grows tall and heavy. Without soil for anchorage, we install an overhead trellis system for structural support. Fueled by perfect nutrition and 20 hours of light a day, the vegetative stage explodes. The lighting system mimics the long Arctic summer days, ramping up intensity to drive maximum biomass production. Oscillating fans simulate wind stress. This mechanical agitation triggers the production of lignin, strengthening the stalks. On a microscopic level, stomata open to exchange gases, inhaling CO2 and exhaling oxygen and water vapor. Precision agriculture relies on data. We track growth rates daily to the millimeter. Even in a sealed environment, vigilance is constant. We scout for pests that might have breached the perimeter. Instead of chemical pesticides, we deploy biological warfare. Ladybugs are released to patrol the canopy. These predators are efficient hunters, keeping aphid populations at zero without contaminating the crop. To further armor the plants, silica is added to the reservoir. It reinforces cell walls against pests and disease. The corn enters the jointing stage. The stem elongates rapidly, pushing nodes upwards. The stalk is now thick and robust, comparable to a thumb, ready to support the weight of the ears. Below, the root zone has become a dense mat, maximizing surface area for nutrient uptake. To improve airflow and redirect energy, the lower, shadowed leaves are pruned away. Nothing is wasted. The biomass is collected for on-site composting, closing the loop. The crop reaches its vertical limit, towering at 1.5 meters, leaves brushing the light fixtures. To prevent heat burn, the LED arrays are hoisted higher, accommodating the canopy's final stretch. The reproductive phase begins. The tassel, the male flower, crowns the plant. Tiny anthers dangle from the tassel branches, loaded with millions of pollen grains. Simultaneously, halfway down the stalk, the embryonic ear pushes out from the leaf axil. The silks appear, the female flowers. Each individual silk connects to a potential kernel on the cob. In nature, wind does the work. Here, we manipulate the airflow to shake the tassels. A golden rain of pollen descends, searching for the silks below. To guarantee full cobs, we don't rely on chance. We perform supplemental hand pollination. The brush gently gathers the viable pollen from the anthers. This pollen is then painted onto the waiting silks, ensuring every strand receives a grain. The silk is sticky, designed to capture the microscopic pollen upon contact. A pollen tube instantly begins to grow, tunneling down the entire length of the silk to fertilize the ovary. Once fertilized, the silks detach and dry out, turning from white to a deep reddish brown. The kernels begin to fill. The ear swells, becoming heavy and solid. We shift the nutrient recipe again. High potassium is pumped in to support fruit development and sugar transport. Nitrogen is dialed back. We want the plant to stop growing leaves and put all its energy into the grain. A tactile inspection confirms development. The ear should feel firm and fully filled to the tip. The husk is the wrapper, keeping the kernels moist and protected from the dry facility air. With pollination complete, the tassels are removed. This forces the plant to stop supporting the male flower and send all nutrients to the cob. The facility's sensors detect a drop in humidity. Automated misting systems engage to prevent plant transpiration stress. Inside the controlled environment, precise humidity management creates a morning dew effect on the canopy. A final inspection of the root zone confirms the plant's structural integrity before harvest. The corn silk has turned a deep brown and dried completely, the primary visual indicator of physiological maturity. To verify the grain fill, we perform a non-destructive check on the husk. The kernels are revealed to be in the perfect milk stage, plump and pale yellow. A gentle pressure test confirms the moisture content. The milk should spurt, not ooze. We verify the sugar concentration using a digital refractometer. The reading indicates optimal sweetness levels for this specific Arctic variety. With quality confirmed, the harvest tools are prepared. The harvester secures the ear firmly, positioning the shears for a clean cut. A precise incision separates the fruit from the hydroponic stalk. The final snap releases the cob, signifying the end of the growing cycle. Harvested ears are cradled gently in bamboo to prevent bruising. The harvest continues efficiently down the length of the hydroponic module. A full basket represents the success of high-tech agriculture in a frozen wasteland. The produce is immediately transferred to the preparation area to maintain freshness. We remove the outer husk layers, which may be tough or slightly weathered. Stripping the inner silk reveals the pristine, golden kernels beneath. Meticulous removal of remaining silk strands ensures a perfect culinary experience. The result is a flawless specimen of Arctic-grown maize. A wash in purified water removes any starch dust and preps the corn for cooking. The water amplifies the color, making the yellow pop against the metallic surroundings. We trim the fibrous stalk end and the tapered tip for uniform presentation. The prepared corn is racked on stainless steel, ready for the kitchen. Back in the grow module, the cycle must be reset. Post-harvest cleanup is critical. The remaining biomass is harvested for recycling. We extract the root matrix from the hydroponic channels. These roots are dense and waterlogged, having filled the entire volume of the pipe. The channels are sterilized with hydrogen peroxide to prevent root rot in the next crop. Mechanical scrubbing ensures no biofilm remains. Stalk. The machine reduces the plant matter to organic mulch instantly. From the lab to the living quarters, the view changes, but the cold remains. A large pot is placed on the induction cooktop. The water reaches a rolling boil. The fresh We trap the heat to cook the corn evenly. "10 minutes is all it takes for perfection." The heat intensifies the natural pigments, turning pale yellow into deep gold. The lid is lifted, releasing a cloud of sweet-smelling steam. Tong. Presentation is simple on white porcelain. Melted butter is brushed on, seeping into every crevice. Coarse. Dried parsley provides a visual pop of green. The heat melts the toppings into a savory glaze. Served by the window, the contrast with the environment is stark. Outside, the Arctic storm rages, a reminder of the hostility of this latitude. Inside, warmth and fresh food create a sanctuary. The moment of anticipation. Freshly harvested corn has a distinct, crisp texture. The sweetness and milkiness confirm the data we saw in the lab. A clean cob left behind. Life thrives here, against all odds. The station continues its vigil through the polar night. Arctic Agriculture Research Station, sustaining the future. Production complete.